This conference will now be recorded.
Very good morning to everyone. So, if you remember in the last session, we started with state machines, correct? Yes, sir. So, why always state machines are refers to the finite state machine? Why state machine always is refers to the finite state machine? Why can't it be infinite? If number of states are known, correct? So, it is possible to find out number of flip-flops. So, you can implement as a chip if you know the number of states. If there is an unknown number of states are there, it is highly impossible to find out the number of flip-flops. So implementation of the chip is not possible if we have an unknown number of states. Only known number of states possible to find out the number of flip-flops so that we can configure it and implement the hardware. You know that the finite state machines are two types. What are the two types of the finite state machines are? What are the two types is nothing but implicit finite state machine. Correct. And another is nothing but explicit finite state machine. So we know that there are many applications of the finite state machines, right? Many applications we have, like it is used in robotics, graphics, military applications. Okay, you talk about any graphics, computer operation, design of the chips. In many applications, we will be using the finite state machines. One of the most common usage of this finite state machine is nothing but pattern detector. In many cases, we will be using what? Pattern detector. So use that to build the other existing system of the particular applications. Okay. So implicit state machine is nothing but what? Implicit finite state machine. If user does not going to define the states, okay, it is implicitly defined. Means if user does not going to define the states, those state machines we call it as what? Implicit finite state machine. So examples like, so we can call what are the implicit finite state machines is flip-flops. User is not exclusively telling that if my input x is equal to 0 or some x is equal to 1 other value, we're not telling that go from this state to this state. So that happen implicitly. User does not controlling, correct? So those finite state machines, we call it as what? Implicit finite state machines. Even you call about your counters, synchronous counter, asynchronous counter, what you have built. Various counters is example for what? Implicit finite state machine. And some registers you are configured, like CISO, PIPO, serial input, serial output. So that is also example of what? Example for the implicit finite state machine. Then explicit finite state machines is nothing but what? If user is explicitly defining the states. So these finite state machines we call it as a explicit finite state machines. So examples, if you talk about the examples of this is nothing but what? TLC means a traffic light controller. So examples in robotics, what you are using to change the states. User is controlling to change the states from one state to the another states. So other example is robotics and many applications, pattern detector, okay, your elevator, okay, lift operation, refrigerator, microwave oven. So these are the examples of what? Explicit finite state machine. Again, explicit finite state machines are two types. Those we call it as what? Millet model. Correct. Another one is Moore model. Millet model and Moore model. What do you mean by Millet model? So output, correct? Output depends on the present state and input. Means and input means present input. So this circuits machines we call it as a Millet model. What is Moore model is? Output depends on the only the present states. Only the present states. We call it as a Murray model. So Millet model is more prone to the errors because output is directly depending upon the present state as well as the present input. The change in the input will also affect the output. Clear? Be more sensitive towards the what? Noises. So not more prone to the error. Murray model is output is depending only on the present state. Compared to the Millet model, Murray will be less sensitive because it is depending only on the present states. Present states. Okay. So what is a state machine? What is a state machine? State machine is a diagram, correct? Is a diagram which gives the relationship between one state to the another state. State machine is a diagram. Is a diagram. So which gives the relationship between one state to the another state. One state to the another state. Another state. Did you understand? Okay. So is it which one we can preferably use, implicit or explicit? Explicit. Why? User have a control over on the states, correct? So we can go with the explicit most of the time. We can't tell that implicit is not at all used. It is used, correct? If you see counters, if you want to do then what you want. Implicit means flip-flops you need. Okay, like if you want to define any state machine. So what is the use of the state machine is, you can reduce the manual effort, that's it. Any process, any algorithm, you transform then the state diagram, convert your state diagram into the what? State machine. So one example, good example is nothing but a traffic light controller. Is it clear? Where humans are not standing and wasting their time throughout the day, right? So we replace the human effort by what? Machine, correct? So that can be using what? Using the state machine to represent the state. Of course, hardware is required. How these states are changing, that we have done using what? Using state machines. Are you clear? So these are the two types of the explicit state machines. So one example will be talking about the state machines is pattern detection. Last session also we talked about pattern detection, right? Pattern detector we call pattern detector, or we can also call it as what? Sequence detector. Sequence detector. So last class we talked about the pattern detection. I want to build a state machine. Let us consider this is a state machine. Finite state machine of what model? Let us consider Millet model. Millet model. So what could be the inputs to this? What are the inputs to this? Of course, this is a sequential circuit. Clock is there. If there is a clock, you can also write what? Reset is there. Reset is there. And what do we have? Another input. Another input and outputs are. So we need a one input, right? We need a one input. Let us consider this nothing but I am giving D input. Okay. Then one output is required. This is nothing but one output. Let us call this nothing but pattern output. Pattern output means this is a state machine I want to design. This pattern I want to detect. 1, 0, 1, 1. Let us build this using what model? Millet model. So two types Millet model detection you can do. With overlapping what? Without overlapping means non-overlapping. Non-overlapping. So what this state machine should do, if I'm giving the finite length of the sequence like this, correct? This is a D input I'm giving to my state machine, correct? Whenever this pattern matches, whenever this pattern detects, then output should go to what? High. Else, what is output should be? 0. Correct? If I'm talking about non-overlapping sequence, can you match the pattern? Which pattern it is? This is your D input. Correct? What is the pattern? T out? 0. Correct? 0, 0, 0, 0, 1. There's a pattern matches here. Again what? 0, 0, 0, 0, 0, 0, 1. Here one more pattern matches here. You can understand. Next is what? 0, 0. Is it 1 here? No, right? Why no? Because it is non-overlapping. So non-overlapping 0. Again this is 0. You understand? So I want to build this. I want to build this finite state machine. This should detect this pattern. 1011 pattern. What pattern I was talking about? Millet model non-overlapping pattern. Did you understand? So to write a Verilog program to this, what do you need to write a good Verilog program for the state machine? What do you need? We need a state diagram. In digital part, you understand that if we give the pattern, so based upon pattern, you are going to run a state machine. Then using steps like states and all, you are building the hardware circuit and a state machine. Now we should write a Verilog program to this. Verilog program to this. So this is the one. I'm talking about what? Millet model. Correct? So Millet model, we know that output depends on the present state as well as the present input. So if I write the Millet model to this state diagram to this sequence, can you write a state diagram to this? What are the states I should have? How to write the state diagram to this? First, let us write the reset state R. R I can write what? Got nothing state. If got nothing state will receive. This is a got nothing state. For the Millet model, how many states are required? 4 states are required. So very first state is nothing but got nothing state. So this indicates the reset state. Correct. If got nothing state receives 1, so where it is going? Next state. What is next state I can write? Got 1 state. So Millet model I am writing. The output is depending upon the what? Present states as well as the present input. I can write like this. Output is 0. This one indicates what? T in input. This is nothing but your T in input. This is nothing but what? Output, pattern output. I can write the pattern output. Did you understand? D input and pattern output. If got nothing receives 0, same state. It remains in the same state. What is the input is? What is the output is? 0. If got 1 receives 1, same state. It remains in the same state. I can write like this 1. What is the output is? 0. If got 1 receives 0, it is one state. What is the next state is? Got 1 0. Got 1 0 receives 1. Next state. What is next state is? Got 1 0 1. What is the output is? 0. Here what is the output is? 0. If got 1 0 receives 0. Is it same state? 1 0, whether 1 0 is pattern is matching to 1 0. Once here is already 1 0 is received here. Detected here. If I get 0, whether my pattern is matching to this? No. So that what I'm going to do? Go to the reset state. Input is 0, output is 0. If got 1 0 receives 1, this is I'm talking about non-overlapping. Non-overlapping. Where I can go? Reset state. Oh. Non-overlapping. Input is 1. What is output is? 1. If it receives 0, already 1 0 1 it is received. If I receives 0, using this whether I can match the pattern? 0 1. This 1 0 is matching, right? Wherever it is matching, G1 0 is matching, I'll go to what? G1 0 state. What is the input is 0? What is the output is? 0. You don't understand? Got nothing state, got 1 state, got 1 0 state, got 1 0 1 state. Did you understand? Now, how many states are there? What is the n value in this case? Is capital N value. How many states? 1, 2, 3, 4. There are 4 states are there here. If there are number of states are 4, how many number of flip-flops are required? 2 flip-flops are required. Then you know how to build a FSM to this using a excitation table, transition table, correct, state table. So you are building the digital circuit. Now, this state I can represent since 4 flip-flops are required. This state represent, how I can represent this state is, I can represent 0, 0, correct? I can represent this is what? 0, 1 state. I can represent this state is what? 1, 0. I can represent this is what? 1, 1. To represent the states, what code I am using? Binary code. So what I am doing here is nothing but got nothing is represented what state? 0, 0. Got 1 state is representing what? 0, 1. Got 1, 0 representing what? 1, 0 state. Got 1, 0, 1 representing what state? 1, 1. This is nothing but binary. One example we already saw that in asynchronous repo, if I'm using binary counter for the read pointer and write pointer, one problem is correct. Since I'm using binary code, there are changing from one state to another state. It is going some intermediate states. Because of that, it produces what? Glitches. Correct. Here also you can see changing from G1 to got nothing 1 to got 1 0, 0 1 and 1 0. Right. If I'm using 2 flip flops here, so here both are changes. Since it is only number of states is 4, it's fine. Only this number of states are 0 0 0 1 1 0 1 1. Imagine the n is equal to 100 states are there. N is equal to 100 states. Number of flip flops, how many flip flops are required? 7 flip flops are required. If I'm going to use the binary code, say for example 7 to 8 it is changing. So that all flip flops should changing, right? 7 to the 8. To change from one state to another state, if I'm using the binary code, it goes with a few intermediate states. So to avoid that, if you remember in asynchronous counter, we go with the gray code. I'm using just only 1 bit changes, successive bit. Now here what code I can use to avoid this problem? 1-hot encoding. You understand? I can go with what? 1-hot encoding code. What is a 1-hot encoding code is? 1-hot encoding code. This 1-hot encoding code I can represent like this, right? This state I can represent what? 0, 0, 0. And since I have 4 states, I have 4 states. I have 0, 0, 0, 1. Correct? This is what? 0, 0, 1, 0. This is what? 0, 1, 0, 0. This is nothing but what? 1, 0, 0, 0. If you look at the successive bits, only one bit only changes. Correct? From year to year, here it is okay. Only 2 bits changes, not more than that. How do you understand? So instead of going with this binary number, natural number, I can go with what? 1-hot encoding. So that instead of writing this as 0, 0 state, I can represent what state it is. 0, 0, 1 state. This is what? 0, 0, 1, 0 state. This is what? 0, 0 state. This is what? 1, 0, 0, 0 state. You understand why we go for the 1-hot encoding? Basically to avoid the what? Glitches. Correct? Did you understand? So this state I can write. So this 0, 0, 1 state I can write in this form. I can write like this. S underscore R indicates that reset state. The state is reset state. This state what I can write? This state how I can represent? Shall I write got 1 state like this? I have detected 1. This state how I can write? Yes sir. 1, 0 state. This state how I can represent? Yes sir. 1, 0, 1 state like this. Or you can name anything, no problem. If you are taking 1 is a bike and 0 is a car, correct? Now this is S underscore R. This is what? If I'm representing 1 is a bike, okay, 0 is a car, again bike. This pattern I want to detect. So my initial state is what? Reset state. What is next state I can write? 1 bike detection. There is nothing. This state how I can write? BC. This state how I can write? BC. B. How you want to represent? You can represent the states. Did you understand? Now, if I want to write a Verilog programming for this one, what are the inputs I have to this? Gain is a one input, clock is a one input, reset is one input. Did you understand? What is output is? Pattern out is a one output. So along with this, shall I use the one more input to this? One more input. That input I call it as what? Valid input. Imagine your encounter, parity encounter. One more output you are representing there. When your valid is equal to 1, you are saying that I am doing the proper encoding. Here also, if my valid is equal to 1, whatever the input I am giving, based upon this, output should produce, then it should detect the pattern. I am saying that when valid is equal to 1, you perform this, what? Pattern detection. When valid is equal to 0, there is no pattern detection operation. How do you understand? So that I can use one more input is nothing but what? Valid input. Now you tell me in this what are the input ports are? What are the input ports? Input ports are what? Clock. First common signals will write. Clock, reset. I can take this valid also, and now I am grouping with the what? Common signals. My input is what? D. This is a D. How many bits D in input it is? 1 bit, or it is a vector? 1 bit, correct? This is sequence, long length sequence. I'm giving for each clock pulses, I'm giving what? 1 bit to this circuit. So this is the input I'm feeding. This input I'm feeding here. Correct? If I write in this case, this is my MSB bits, these are LSB bits. MSB bits is giving for the each clock set. Did you understand? So that D is a vector or a scalar. Scalar. What about the output? Output port? What about the output port? Underscore output is what I'm saying, right? Pattern underscore output. Whether it is a vector or a scalar. You should take what? One. This bit is what? This pattern is detected, I should put output as 1. Could be the input ports. What could be the what? Output. Then also we understand how understand this. Now we need to write the what? Verilog going to model, Mealy model. Then we'll see how to do more model, etc. Did you understand? Now to tell me, so let us make the new folder, okay? So I need a design file. Let us save this into what? Play underscore source. Okay, I think now will be understand. Now also I need a what? TV. Write TV. Okay. Now let us write a design to this. Can you tell me what I need to start from here? Module, correct. Module. Then let me write the end module. Module and end module. So what is the module name I should start? I can start. Relay. Shall I like the underscore what? Then I need to do what? Port list. What are the port list are? Clock is a one input. Reset is one input. Valid is an input. Correct. Valid spelling is correct. VALID valid. Then D input. Okay. D. Then shall I take pattern out or just I will take out? Out. Okay. Let us take out. Or I can take this nothing but what? Input lines. Is it fine? Now we put the port list. Then we need to declare the what? Port declarations. What are the inputs as? Clock, reset, valid, the input, and the in is the input. Then what is the output? Output reg, because we are modeling in what technique? Here we are modeling. Output reg what I need to write? Out. Correct? I'm going to define the parameters. Now, what is the use of parameters? Like defining parameters, I can easily customize the program. Correct? So all states in parameters I need. What parameter? So first state is what? Reset the state. This state. Yes underscore R nothing matter. Reset the state. Next another state representation is this underscore is one. Okay. Then first step, how many tick B it is? 0 tick B 0 0 0 1. Did you understand? Now let us copy the same. So how many states are there? Another 3 states are there. 3 states and 1. Now what is next state is? First is reset the state, next is one. One detection. The state I am representing yes underscore 1. This I am going to write 1. 0 0 1 0. And what is next state is? 1 0. This I can write what? 1 0 0 state. So to representing the state I am using what code? Instead of binary code I am using what code? 1-not encoding. Correct? So this is a 1-not encoding. Did you understand? So we needed some registers here. States and the next states. So that is not a input and output ports that I am declaring as a what? Regs. So what down to the 0 it is states. Next states and the present state to the present. Read on to 0. Read on to 0. Okay. Shall I write what? Present state, and also what I need? Next state. Present state and next state. Now we did with the what? Port declaration, parameter declaration. Okay. Now I need to start with what? Always at what edge? Shall I use the pass edge? Pass edge of the clock? Begin. Passage of the clock begin. So what I want to begin? If, correct? If reset. Shall I write reset? Or equal to 1 also fine. I can write reset also fine, right? In test bench I put reset is equal to 1. When reset is equal to 1, what I need to do? What I want to do? Output is equal to 0. Correct? Then what I need to do? This present state, next state should be also what? Equal to 0. Present state, correct? Present state, what I need to do? Present state is equal to 0. Then what I need to do? Next state is equal to 0. Then out is equal to 0. Did you understand it? Now what I need to do next? Else begin. Shall I go with the else begin then? Else begin. Here what I need to do? The else begin. What I want to do? Now I should, my valid is equal to 1, I should do this one, detection part. Valid is equal to 0, no detection part. So that I can use it what? Valid is equal to what? 1. Or I can write valid. And then I need to put what? When reset is equal to 0, I should put what? Valid is equal to 1. So I can write valid is equal to 1. Shall I write like this also? Fine, right? Valid is equal to 1. What I want to do? Now I should start the pattern detection. How to detect the pattern? How to detect the pattern? What? So here I need to do the end, right? Here I need to do the end. Okay. How to detect the pattern? What statements I can use to do the pattern detection? I can use this case statement. This is my state. Based upon my input, I'll go to the next stage where. Correct? So I can use the case of what? Case statement of what? Present state. Based upon the present statement, I am deciding if this is my present state. If I give d is equal to 0, I'll go to the next stage. If d is equal to 1, I'll go to the next stage. So that I can go with this one. Present state. Present state. In my present state, what I need to do? If case the present state, what I want to do? If this is what present state. S bar underscore is the present state. Then what I want to do? Now this is my present state, right? S underscore R is the present state. Present state. Now what I need to do? Begin and end. Begin and end. If this is my reset state, this is my present state. Correct? This is my present state. S bar R is the present state. Then what I need to do? Now I should decide if d is equal to 0, where I need to go to the next stage. If d is equal to 1, where I need to go to the next stage. So condition is there. So that I can use the if statement. If of what? If input is equal to what? 1. 1 or 0. 1, right? If condition, if it is true, it will go to the if body. So I can go what? Begin. So if the present state is what? Reset state, SR state. If the input is equal to 1, which state it is going? Next state. What is next state is?
कांटेक्ट करके डीलरशिप ले लो ना सबसे अच्छा
How to write here?
एक साथ में देके जाएगा पूरा माल उसमें प्रॉफिट भी होगा नई दुकान वाला का प्रॉफिट होता है मैं कह रहा हूँ इन सब जो चीज लेके आता हूँ डीलरशिप भी लेगा ना इसका
Next state is equal to what state it is? S state. So next state, correct? Next state is equal to what state?
वो कैसे आएगा
S underscore 1 state.
बात करो ना आगे बात
Correct? Did you understand? Then what is output? Miller model we are doing. What is output is? Output is equal to 0. Did you understand? Then what I need to do? End this.
फालतू के दिमाग
End the
दुनिया
Then what is else
बिजनेस
condition?
ऐसे नहीं होता है
If the input is nothing but what? 0.
ये वही वाली बात बोल रहा
If
हूँ
input is 0, where I am going? What is my next state is? SR state. SR state. Correct? What is my output is? Is equal to 0. Then I can end this.
हमको डेली की कितना कार्टून होगा ये कम से कम
Correct?
3 कार्टून का माल
If my present state is reset state, my present state is reset state, this case will be executed. If your present state is SR state, if input is equal to 1, it is go to the next state is 1. Else it is staying in what? Same state. Now did you understand this case 1? Are you clear? Let me explain with respect to this diagram. This state I am representing as SR state. Correct. SR state. Correct? This is my present state. If D input is equal to 0, this D input is equal to 0, I'm staying in the what? Same state. Next state is what? Same state. S bar R. What is output is? 0. Did you understand? If this is my SR is a present state, if D input is equal to 1, correct? Where I'm going to the next state is J1 state. What is output is? 0. This is what I'm writing here. My present state is what? SR state. If my input is equal to 1, I'm going to the next state is what? 1. Got 1. Else, where I'm going into? Same state. What is output in this case is nothing but 0, 0. Now I should start writing for what? This one. This state is represented what? SR1. If D input is equal to 0, where it is going? Next state. Input is equal to 1. Same state. So that what I can do, I can copy the same program from where to where. I can copy from here 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 10 lines. Correct? So let me write for saying this case, I am going to write the end case also. Yeah, correct? This is the end case. End case. Now how many lines I need to copy to write the next one? 10 lines. Correct? 10. Why? The same thing I'll copy. I'll modify this program. Now what is this case is? S1 state. Correct? The case is S1 state. If input is equal to 1, what is your next? S1 state only. If output is 0. If input is equal to 0, D is equal to 0, what is the next state it is? S1 0 state. Are you understanding? We have done with this. Correct? What is next one? What I need to do next is? Yes, correct. Next is I am copying the same. Okay. Then I am going to modify this. What is next state is? Next is this is 1 0 state. S1 0. If input is equal to 1, which state it is going? 1 0 1 state. Output is equal to 0. Else, which state it is going? SR state, reset state. What is output is equal to? 0. We have done with this. Correct? Now we can go to the last state. What is the last state? Yes. 1 0 state. 1 0 1 state. If input is equal to 1, which state it is going? SR state. What is output is? 1. Correct? If input is equal to 0, yes sir, 1 0 state. What is output is? 0. Millay model, output is depending upon the present state as well as the present input. Now we have done with this. If you want, you can write the default state. If other than any case you are running, I should tell that what? I should tell that wrong state, something like that. Do you understand this? Now what I need to do here? This is the states we are writing for what? FSM. For 1011. 1011. So after this is my end case. Correct? This is the end case. Now what I need to end? End the if valid. Correct? This is my if, right? I will end the case. I should end the what? If. Then I should end the what? Else begin. Then I should end the else begin. Then I should end the what? Always. How do you understand this? Now what I need to do? Always at the rate of what? Next state. Next state. What I want to do? What I want to do? Present state. Always at the next state is, I need to assign this. Present state is equal to what? Next state. Why I need to do this? See, first my present state is reset state, right? When this is reset state, what happens here?
चेक बन गया
I am going to run this. Then what is my next present state is? What is my next present state is? Guess one state. Now I should assign the next state to what? Always at the next state. I should assign the next state into the what? Present states. To run all the different cases. I think now you understand this. Correct? Now this will done with the what? Design of the 1011 pattern detection. Are you understand? Now let us run this for the debug section. Any syntax errors. Let us run this.
बालाजी का एजेंसी नाम होता है बालाजी का हम बात क्यों कर रहे हैं नहीं बात करता है बालाजी कम से कम काश सुपर का पैकेट कम से कम कहाँ पे भी होगा जो इतना आप लेके आप करते हैं कार भी यही होगा तो
No syntax errors. Now let us go to what? Writing the test bench to this. How to write the test bench to this? First, what I need to do? I need to include the file. Include. What is the name of this file I am giving is? Melee_non_overrun. So Melee underscore non-overlap underscore non-over.v file. Then what I need to write? Start with the what? Module tb. Then what I need to do? Shall I copy all this, correct? And then convert all the inputs to the what? Reg data type. Convert all the input to the reg data type. So first let us, whether I need to go work with these parameters in my test bench. Let us keep here. If I am using, I will keep it, or else what I am going to do? I am going to remove this. Now I am going to change this into the what? Reg data type. Then again I am going to change this into what is this is? White. This is nothing but white. And this I am going to declaring as a reg 3 down to 0 present state and next state. Now what I need to do? Module instantiation. Design file instantiation, right? What is the name this I have given is Melee_non. So let us copy the same line. Copy the same. So now I am going to instantiate it. What I need to instantiate? Name of the design, then what I need to do? PUT. This is fine. Port connection by what? Order list. Correct? Then what I need to do? I need a clock. Clock generation. Always begin. Correct? Then what I can write? Clock is equal to 0. So let me give the time period of 5. Correct? Then the clock is equal to 5. Sorry, 1. Hash of what? 5. So this does the job of what? Clock generation. Did you understand? Next, what I need to do? Initial begin and end. Now in the initial begin, what I need to do? Reset is equal to 1. Reset is equal to 1. Then what I need to do? Reset is equal to 1, I can give the delay. Shall I go with the repeat? Correct? Repeat it 2 times of what? Always at what? Pause H clock. I'm delaying this much of what? Delay. Or you can use like this #25, #10. Okay. Okay, let us go like this. Let us do 15. Let me comment this line. In what I want to do?
अरे वैरायटी मिलेगी एजेंसी में, प्लस वो है कि एक बार लेना स्टार्ट करोगे तो वो भी आपको दूसरी बार तो पेमेंट देना ही पड़ेगा.
When reset is equal to 1, shall I make din is equal to 0?
भाई ये
Is it fine?
भाई ठीक है भाई
Huh?
हाँ तो बोले क्या
Dean is equal to 0. Next, what I want to do after this, when reset is equal to 0.
नंबर तो वो मांगेगा सर
Now we need to assign the D input, generate the input. To generate the input, shall I go like this? Repeat. What is repeat statement is? If I use D in dollar symbol random, how many bits it is generated? Dollar symbol random, 32 bit. Now D becomes 32 bit. I want very long length sequence. Correct? So that I can go with the repeat statement. Repeat 500 times. How many times I want to repeat? 500 times. Begin, correct? Begin and end to this repeat. So how many times it is going to repeat? 500 times it will. So where I want to repeat this one? Always when it comes what? Passage of the clock. Always passage of the clock. What I want to do here? D input, right? This is not D input, right? I am using this as an input, sir. This is an input. Then input is equal to what? Dollar symbol random. Dollar symbol random. If you want to include the seed, you can include the seed to this. Did you understand? Next, what I want to do? What I want to do? I have applied the input right here. Then after this repeat, so after repeating this, always passage of the clock, then what I am going to do, D is equal to 0, I am going to D is equal to 0. So this will repeat how many times? 500 times. After repeating the 500 times, what I want to do? Then at always positive edge of the clock, I am making what? Input is equal to 0. And also I can make what? Valid is equal to 0. Here I can also make what? When I want to do the pattern detection, valid is equal to. Did you understand? If you want to declare valid is equal to 0, at the reset is equal to 1, I can write here also what? Valid is equal to 0. Or do you understand? Now we are done with the test bench here. Is it clear? Now what I need to do here, I went the what? I need to give the finish time. So let us give the finish time is 500. Dollar symbol what? Finish. Then end. Then what I need to do? End module. How do you understand? So I'll do the small changes in my design file. What changes is, when reset is equal to 1, instead of making this present state and next state to 0, I can make what state? Like this, reset state. Correct? Next state also I can make what? S1 R, S and R state. 0 means what? Same, right? It should be an ideal state. Instead of 0, I am writing what? Reset state. Now let us save all. So let me change here also to check the syntax error. This is S1 reset state. This is also what? Reset state. How do you understand? Now let us run this first. Then I am going to run the test bench. Let us compile this program for the test. Syntax error. This is state. Suppose I want to count. Okay, let us run. Then later we can count. I want to count that how many number of times this pattern detector is counting. We'll see that later. Do I need this line when I'm running in the online simulator? No, right? Because I included the design file here. This is my test bench. Now let us run. I'm not using these parameters anywhere in my program. Shall I delete this? Did you understand? I'm going to delete this. Are you clear? Now let us run this for the syntax errors. So I'm working with fine. Okay. You can use one more initial block here. You can monitor. So since this is not supporting for generating the wave, I have to go with what? Monitor or display kind of things. Did you understand? Now this is fine. Now we should write the what? Run.to file. Correct? So let us delete this. Let us save all. Save all. We'll see now whether it is detecting the 1011 pattern or not. Now let us copy the run.to file. Okay, what we have in the run.to file? glib, work library, correct? Then VLOG, TV. Then what we have? vSync. I think this is not required. This is required for the Costa SIM. So I need to suppress the TV so that I should include that one. For the model SIM, it is not. So vSIM TV, then add with icon position, correct? Then run all. So this is my one. Run.to file. Did you understand this? Now let us compile this program.
पापा ने सब्जी अलग बनाई है, चटनी एक साथ बनाई है, साग एक साथ।
How can you analyze the output waveform? Okay, let us keep this is my zoom this and keep the present state and next state to the unsigned. Okay, and this is my output. This is my reset. This is the reset. So this is the valid. Valid becomes a here. Okay, and this is the input. This is the input. Random input we are applied to this. Correct. What is our pattern is 1099. So let us check where my output is I. Here output becomes I here. What is the pattern is? Pattern is 1099. So always this output will get after 1 delay. Correct. Now you can see this is a pattern here. This is a D input. From this clock to this clock is input is 1. Correct. What is our pattern is? 1. Now this is 1. Correct. This is what? 0. From during this clock period, this is 0. Again, next is what? 1. Next is what? 1. So that in the next clock cycle, I am getting output is equal to 1. Right? Did you understand? This is 1011 pattern. And here also it becomes I. What is the pattern is? Detecting 1011. Output is I. Did you understand this? Again, where next output is here. Next output becomes I here. What is the pattern is? 1011. Non-overlapping. Again, where the output is I here. Now again output is I here. What is the pattern is? 1011 pattern, therefore output is I. Did you understand this? This is working as a overlapping. Non-overlapping. Did you understand? Now I want to see for this one, I want to see that how many times output is I. Here it is output is I. How many times output is I is 1 time. Let us keep the clock here. The next is what? 1, 2, 3, 4. So 1, 2, 3, 4, correct 5, 6, 7, 8, 9, 10, 11, okay, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. For this, repeat. I'm repeating how many times this random into the random is I'm repeating for 500 times. Did you understand this? How you understand how to do this? Now I need to count this. How many times my pattern is detected? How to count this? How to count? Test bench. How to count this one? I can declare one variable. Okay. Let us declare the variable is integer. Integer what? Let us make it variable name is nothing but count. Integer count. So what I'm going to do, I'll take one more always block. Always at what I want to do. Always at what? Output. Always at what? Out. Always at the out. What I want to do? I want to increment the count. Count is equal to what? Count plus 1. Count plus 1. Correct? Then where I need to print this? Here. After here or what? Where I need to print this is. If I print here, I need to print this here. After detection of this correct pattern, here I can use the what? Dollar symbol display correct? What I want to display? Count is equal to percentage D. Then what is argument I need to pass? Count. Did you understand? Are you clear? Now let us save all. Now compile this program again. So it is printing for all the what? 500 times, right? Because I am repeating how many times this is? 500 times. So then where I need to print this? So this I should print, not inside the what? Inside the what? Repeat, right? So once I do what? Pattern detection. Shall I print it here? Did you understand what happens if I'm going inside this repeat? That will repeating how many number of times? 500 number of times. So once I do the pattern detection, then I'm calculating the count here. So before going to this, when input is equal to 0, or I can do here also, no issues. All I need that I have incremented the count. I can display the count here or I can display the count here. So this will take what? Valid is equal to 0. What happens? Valid is equal to 0 means what? D is equal to 0. Whatever the input 0 means what? In our case is car. Car comes also, I'm not doing the pattern detection. So when I'm doing the pattern detection, the valid is equal to 1. How do you understand? Now let us save this. Run this program. Now this is a count, but count is not getting incremented. So let us check the program. Always this I should write what, correct?
I have
Pass.
initialize the count equal to 0, sir, and reset equal to 1.
When reset is equal to 1, okay. So
We have
reset is
initial
equal to
count.
1.
We have to
to
initialize
what?
count.
Initially, count is equal to 0. This is the one I think do. always at the pass edge of the what? Output. Then count is equal to what? Count plus 1. Now let us save all.
हाँ
देना देख रही देना तो फिर देख रही को चल के
Count is equal to 28, but what we are counting is wrong. Let us count it again. Okay. So it is giving the number of counts. How many number of counts is nothing but 28. Let us calculate the counts again. 28 or 29 we are getting. 20. Okay, let us see this. This is the first count, right? Count 1. And this is next count is 2, 3, correct? Let us zoom this. 1, 2, correct? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So let us take 18, 17 up to here 300 picoseconds. Up to below 300 picosecond, what is the count is? 17. Now let us drag this. Now this is what? 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. And here also it is giving the count, right? My here, what happens here? My value goes low. Let us check here, any pattern is there here. Pattern is there. 1, 0, 1, 1 is there. So total counts, it gives me what? 29, but why it is giving 28 it is giving, right? 1. It's postage 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. What happens? Here, up to here, this my value is equal to I. Correct? How come it is printing 28? It should be 29. Correct? Okay. Let's understand this program. I'm printing valid is equal to 1. Random generation of the input. Then I'm displaying the count. So can you debug this program? Always at the positive edge of the pass edge of the out, and we are making count increment. So we are initializing count to 0 here. Now count is equal to 20. So what is the changes in this program is at this positive edge only I'm trying to add in the count. That's why it is counting how many clock edges. Means always when the positive edge comes, it is counting only 28. So now I can print this way. At this positive edge also I have a count, so that I can print the display here. Did you understand? Now to remove that spaces, I can go with what? 0. 0 T. Did you understand? Now can you write it for, can you write the program for overlapping? Overlapping. Write the state diagram for the overlapping. Yesterday I think we wrote that. The same pattern I was taking. Correct? This program is clear? Okay. Now the same one, same pattern I do it for what? Overlap. How to do it overlap? Overlap. This is a sequence. 1 0 1 1 sequence. How to do the overlap? First I can go with what? Got nothing state. If it is 0, stay remains in the same state. If it is 1, go to the got 1 state. Output is 0. If it is 0, what state? Got 1 0 state. Output is 0. If it is 1, stay remains in the same state. If it is 1, what state I can go? Got 1 0 1 state. Input is what? 1. Output is 0. Here if I receive 0, I'll go to what state? Reset state. Now here, what I need to do? If it receives 1, which state I should go? Got 1 state. Instead of going to the reset state, this is what lapping? Overlap. Correct? Overlapping. What is the input is? 1. What is output is? 1. And this is nothing but what? Go to the, when it receives 0, go to the what? This state. Got 1 0 state. Only changes to the overlapping is what? When you detect the sequence, in the previous case, you are going to the what state? Got nothing state. Non-overlapping. In the overlapping, you are going to the what state? Got 1 state. Did you understand? Everything is same then. Only I need to change this. When it is got 1 0 1 state comes, if input is equal to 1, which state I should go? Got 1 state. What changes I want to do in this program? Can you tell me? Shall I make all this? Okay, let us make a folder here. This is Melee non-overlapping. Non-overlapping, correct? No. I want to copy all this here. I want to copy here. Okay. Now what I'm going to do? Non-overlapping. Overlapping. Make one more folder. Melee overlapping. Overlapping. Is it fine now? Now I copy the same files to what? Here. Here is used here. That's why I'm getting here. It is not copying. Let us close the model. Close the terminal also. I'm going to retry. Now coming to this, first let me remove all this one, everything. Now I can make this into the what? Overlap. Now what I need to do in this case is, when it is what state? 1 0 1 state, instead of going to the what state? Reset state, you should go what? 1 state. Any other things I need to change here? No, right? Remainings are same? Okay, now let us save this. Save this. So then here I can make, instead of this non, I can make what? Overlap. Over. Let us save all. The test bench. The test bench, what I need to do? This is overlap. Yes. Close this one first. So in the overlapping, now I need to make. Okay, I need to save this as what? Overlapping, right? Overlapping, this is correct. Here I need to change this into the what? Overlap. And then module instantiation. This is nothing but over. Rest will be the same. Correct? Now let us run this code. Okay, can you analyze the output? This is output. What is overlapping is, what is our pattern is? 1011. Output became psi. Also, this is also overlapping here, right? 1011 output is I. So number of times, what is the count is 32. For this pattern, whatever we are repeated, for this, it is 50. 29 plus 3, right? 29 plus 3. In the non-overlapping, it is 29. The overlapping count is 32. So now here, my pattern is 1011, output is I. Again, it is overlapping. 1011, output is I. Here, 1011, output is I. Here it is 1011, output is I. So next, here 1011, output is I. The next, where my output is I is here. Here 1011, output is I. Here also now it is overlap. 1011, output is I. Here also it is taking overlapping this 1011, output is I. So I think now you understand how to model the Mealy model. Mealy model, correct? So Mealy model using what? Both overlapping and non-overlap. Now can you write the Moray model to this? Same pattern, you consider the same pattern. 1011. What is Moray model is? Moray model, output depends only on the present state. So can you do it for non-overlapping? Non-over.
तो आवाज हो जाएगा तो सही है ना कैसे
What is the present state I can write?
हाथ में चलता है नहीं होगा
Reset state and got nothing state. Got nothing state receives 0. It will stay remains in the one. Same state. So but output is depending on what? Only on the present state. Not on the what? Input. Correct? I can write the state diagram like this. Since this represent what? Output. Gn represent what? States. States of the flip-flop. And this represent what? Input. This is the input. Correct? This is nothing but what? Output. This is nothing but what? States. States of the flip-flops. So output is depending only in the what? Present states, not on the what? Input. In previous case, we are writing like this. Bar 0, where output is depending upon present state as well as the what? Present. So this is the Moray model. What is next state? If it is 1, it is going to what state? Got 1 state. Got 1 state receives 0. Which state? Got 1 0 state. Here output is 0. If this is receives 1, it will stay remains in the same state. This is output is 0. Still we have not detected the sequence. Again here what happens? When this is receives 1, it will stay remains in the what? Same state. No, sorry, go to the next state. 1 0 1 state. What is output is? 0. If this is receives 0, it is going to what state? Reset the state. If this receives 0, going to what state? 1 0 state. If it receives 1, which state it is going? Got 1 0 1 state. What is output is? 1. Correct? In this case, if it receives 0, reset the state. When it receives 0, reset the state. When it receives 1, which state it is going?
चलो कुछ बोल
got
रहा है क्या कह रहा हूँ
one
बात
state.
करके वो ज्यादा फायदा रहेगा
Non-overlapping.
नहीं इधर आएगा समझ गए
My pattern detection has been done. What is the use if I'm going with the reset state? My intention is next what I need to do. I need to start from what 1011. Instead of going to the reset state, if I receive one, I'll go to the what state. Got one state. Are you understand? This is nothing but non-overlapping. How many states are there here? 5 states. Shall I write that this is S bar R? This is nothing but what? S bar 1, S10, S what? 101. This is nothing but what? 1011. I can do the 1 or 10 coding for this state. This state I can represent what? How many states? 1, 2, 3, 4, 5 states are there. I can write what? 0, 0, 0, 1. This is nothing but what? 0, 0, 1. 0, 0, 0, 1, 0. This is nothing but what? 0, 0, 1, 0. This is nothing but what? 0, 1, 0, 0, 0. This state I can represent what? 1, 0, 0, 0, 0. Are you understand? Now we'll see how to model the word. Moray model. Moray model. So let us write a program to this. Moray model. Overlapping or non-overlapping middle? Non-overlap. Non-overlapping. Let us save this as Moray non_overlap .v5. Then we need a test bench. I can write tb.v5. Can you tell me quickly what I need to start? Shall I copy the same program? I can modify, or I want to type line by line. Copy the same. Okay. Let us copy the same. Let us copy this. So this is my design file for Millet model. To copy this to correct. Now the inputs are same. So this I can write what? Moray model. Overlapping or non-overlapping? Non-overlapping. Clock reset valid input is same. Then how many states will be there? Reset state, this 5 tick what? 0, 0, 1. This is what? 0, 0, 1, 0. This is nothing but what? This should be 5 tick. 5 tick. Here also 5 tick. This is what? 0, 0, 1, 0. Again, this is what? 5 tick. 0, 0. Correct? This is 0, 0. Then I should remove here. 1, 0, I should remove. Here also I should remove. I can add the 1 here. Now I need to copy. One more state is there. Let us copy this. Then this is 1, 0, 1, 1 state, 5 tick. This is 1, 0, 0. Did you understand this? Next, what I need to do? Input. Inputs are what? Input, clock, reset, valid in. Output is out. Then range, how many down to 0 it is there? 4 down to 0. This 4 down to 0. And always at the positive edge of the clock, if reset is equal to 1, present state, next state I can write what? S bar R or S bar R, and output is equal to 0. Then how to write? How to write the Moray model output? What is Moray model output is? Output depends on what? Only the states, not on what? Input. Then how to represent this? 95% of the program is same for the Millet model and Moray model. So where you should write this output is, what you need to do? Remove this before going to this. Then you can write what? Output. Before going to this, you write the output. That's it. Here I am going to write the output. Output is equal to what? 0. That's it. Did you understand? Here also, what I need to do? After end, what I need to do? Say, okay, what I, when validity is equal to 1, we are beginning. Case present state. If my present state is what? Reset is state. If input is equal to 1, which state we are going? Next state.
ये
Output
खाली
is
का
what?
मतलब वो
Zero.
ना खाली जा
For this state.
खाली
Correct?
खाली का
Else, what I want to do? What is else? Else, if else is nothing but what? Input is 0. Input is 0, which state we are going? Next state is nothing but what? Same state. Remains in the same state. So I need to remove this here. Where I want to keep this is. Where I want to keep after this end. Correct? Did you understand? Only the difference is this is all. Are you clear? Relay is output is depending upon the present state and present input. Now this output is depending upon this input, no right? It is not depending upon this input. Next state is depending upon what? Next state, this output is depending on not on the present input. It is depending only on the present state. So what is my present state is? Reset state. So that I am getting the output here. It is not depending upon the what? Inputs. Are you understand? Now this if input is equal to 1, I am doing this, going to next state. Now I am ending this. Again output is 0 for this present state. Else begin, next state is what? Same state. Are you understand? Only difference is this is one. Next what I want to do here? If you are not giving here, but this state output, yeah, because I'm in this case, this reset state, this is my state now. So I can give only here also. Fine. If you are not giving here also, no issues. Because for this state, what is my output is? Output is equal to 0. Okay. Next, here what I need to do? I need to remove this, correct? Here also I need to remove. So once I go to this state, what I need to do? Out is equal to what? Out is equal to 0. Correct? Did you understand? Again, next, what I need to do? This output I should remove here. This output I should remove here. Then I will go here. Then in the output. What is output in this state is 0. Next. Next is what state? Is 101 state, right? Let us remove here. Let us remove this here. I am going to keep this is here. I need one more state, right? For what? More model. So one more state shall I copy from to here? From here to here I need to copy. So how many lines are there? 8 lines are there. 8 y. Then I'm going to keep it what? P. Now what is this state is nothing but 1011 state. What is output is? 1. So what happens when input is equal to 1? Which state it is? Next state, what is next state is? S1. If input is 0, it is going to the reset state. That's it. Are you understand? S0? See, yes, 1011. If it is 0, it is going to what state? What is 101? Okay, it should go to the 101 state. Correct? And if it is 1, sorry, when it is 1, it is going to 101 state. When it is 0, it is going to what? 10 state. Correct. You can understand. This one I am talking about. This is my state, 101 state. If it is 1, it is going to this state. If it is 0, it is going to what? 10 state. Huh? So, yeah. This is my present state, right? In my present state, I should go with the what? 1011 state. Correct. So when it is 1011, if it receives 0, where I'm going? 10 state. Then this is correct. This state is correct. Huh? So remaining things are same. I think there is a one end is missing here. I need to put the end for this begin. So this end for this begin. Actually, this end and begin is not required because only one statement is there. Correct. Only one statement is there. This is not required. Let it be. Okay. This is else begin. And for this statement to begin, case statement begin. And here also same two ends. Okay. So rest will be the same. Are you understand? So always at the next stage, what I want to do? Present state is equal to next stage. Now let us save all. The test bench, what I need to do the modification? This is a Moray model. Let us remove this William model. This is my test bench. Did I copy the same test bench? Huh? Okay. So let us copy this test bench. Now what is the changes I need to do? Here it is a Moray, non-overlap. Then in the DUT, what I want to do is nothing but Moray, non-overlap. Edge 4, okay. Next, all remaining things are same. Correct? Now let us save all. So copy the run.do file to this. Just copy to here. Let us remove this one. Just close this. So run.do, what is run.do? tb.v. Name I have given is tb. So this is a Moray model of non-overlap. So can you understand the output? Moray model. What is the sequence is? 1, 0, 1, 1. Output is 1. Correct? Here also what happens? 1. This is 1, 0, 1, 1. This is 1, right? 1, 0, 1, 1. But what happens here? So what is our pattern is 1, 0, 1, 1, right? Non-overlapping 1, 0, 1. Let us check this. 1, 0. This is output is 1. But it is not working. It is working for 1, 0, 1, 1, 0 pattern. This is my D input, right? This is a D input. 1, 0, 1, 1, 0. Then this becomes 1. Okay, let us label this 1, 0, 1, 1, 0, output is 1. Again, this is, now it is working fine. 1, 0, in this clock is 1, and then in this clock is 1, output is 1. Okay, I'll figure out the mistake. This is 1, 0, 1, 1, output is 1. But in this pattern, what happens here? 1, 0, 1, 1, 0 also it is considering to what? In the pattern. But look at this, here it is same pattern. 1, 0, 1, 1. The next clock cycle output is 1. Further, let us check this here. 1, 0, 1, 1, output is 1. Again here, 1, 0, 1, 1, 0. So after this 1, 0, 1, 1, the pattern is 0, still it is detecting. So let us check the waveform to this. 1, 0, 1, 1, 0, again it is 1. One zero one one zero again it is 1. Here 1 0 1 1 output is 1. How many times it is counting is 28 times. Let us coming back to this. So this might got nothing. If this is 0, staying in the same state, it is 1, it is going to the next state. And it is 0, it is going to this state, it is 1, it is staying in the same state. In this case, it is 0, it is going to got nothing state. Now what is pattern is 1, 0, 1, 1. In the next cycle, we should get as an output is 1. Correct. But what happens in this case is 1, 0, 1. Actually, we are getting the output. What is our pattern is? 1 0 1 1, right? So let us zoom this. Here output becomes 1. We are getting the output. Okay. We are getting the output. How is? What is our pattern is? This is a 1 year. This clock cycle, this is 1. In this clock cycle, it is 0. Here it is 1. This clock cycle, it is 1. Again, this clock cycle, what? What happens? It is 1. But output I am getting, since Moray model requires how many states? 5 states, right? Now after this, I am getting output is 1. Correct? It is detecting the pattern. In previous case, what happens? Once you detecting the pattern, it takes 1 clock cycle to what? Give the output. So Moray model requires what? 5 states. So this is my output, correct? 1, 0, 1. Sorry. 1. This in this case, in this clock cycle, 1. This clock cycle, what is the input is 0. Here it is 1. Again here it is what? 1. But according to this, once we detected the pattern, after once 1 0 1 1 comes, 1 0 1 1 comes, it is considering this bit as an input. Correct. Then it is making as what? Output is equal to 1. Output is equal to 1. So what I need to do for this case to avoid this? The Moray model. If my pattern is getting like this, suppose you can see in this pattern. In this pattern, this is 1, 0, 1. The next cycle it is 1. So after one cycle, then it is giving the 1. The problem I am facing is that if my pattern is 1, 0, 1, 1, if it is 0, then pattern is detected. After this 0, it is pattern is detecting 9. This is 1. Okay, let us check here. Sorry, check it here. Now this is 1 0 1 1 0. Then it becomes 9. Moray model. Now pattern is 1011. Then I should get 1. Let us check the program. If my present state reset state, if input is equal to 1, I am going to this state. The next state is 0. In this state, if it is 1, say state remains in the same state, output is 0. Else I am going to the next state. From this state, if it is 0, if it is 1, it is going to the next state. 101 state, else it is going to the reset state. Correct. Now coming to this state, 101 state, if input is equal to 1, input is equal to 1, next state is nothing but 1011, else it is going to the 10 state. Should go to the previous state. Yeah, the previous state is 10 state. Now coming here, if my present state is 1011, if input is equal to 1, I am going to the 1 state. S1 state. Here, if input is equal to 0, just make output is equal to 0 state.
इंतजार था सुबह का वो लोग रोते रहे अपना सामान समेटते रहे
Okay, this state, right? And when it is this state, output is also 1, correct? Not 0. This line is not necessary then. So when output is equal to 1, if input is equal to 1, it is going to the S1 state. If input is equal to 0, it is going to the reset state, non-overlapping. So input is also 1, let us move to the S1 state. So 1011 output is equal to 1. So still it's giving the same 1011. The input is 0. Zero one is fine. 1011 here it is fine. Okay, let me debug this. So the pattern See here, if I'm getting 1011, it is giving me as pattern is detected. But problem I'm facing is if my pattern is coming like this 10110, then I'm getting the output is 1. So let me clarify this. Okay. Nothing to worry, I'll clarify this one. So then the same pattern, you take the same pattern. Can you try to do this for what? Overlapping. Now you understand the programming, right? How to model, how to write the Vella program for the what? State machines. You do it, you take the same pattern. So do it for what? Overlapping. Overlapping. So let us give me one more pattern. You try to write both overlapping and non-overlapping to that. So let us take 0, 0. You can take 0, 0, 1, 0, 1. 0, 0, 1, 0, 1. So do this using Millet model. Millet with the non-overlapping. Non-overlapping. And also with what? Overlap. Overlapping. Can you try this for what? Millet also. Millet with non-overlapping and overlap. And overlap. Okay. So I'll be clarifying you why I'm getting this output like this. I'll debug this and then next class I'll clarify this. Okay. So you can take this pattern. So write a Verilog code for the Millet model and the Moore model. This is clear? I think many Millet model, Moore model, you work in the digital system, right? If you want to try for those state machines also, you can write a Verilog program and check the output. Is it clear? So do you have any questions regarding design file of this and then how to generate the test bench? So I was using the case statement, correct? So you can also using your if conditional statement also you can write the program. Is it true? Correct. What is alternate to the if alternate to the if is nothing but what case statement. You can try using if statement also. Yeah, hello.
Sir, when S1011 state come,
When S1?
as 1011 state comes, that time you have to give a if condition just to next state equal to SR state. This is a state only.
You're talking about this pattern, 1011 pattern.
Yep.
Okay, if 101 state comes,
Just you give like if don't give if condition, directly you give next state equal to SR state. Remove all these things out equal to 1 if condition equal to unequal to 1 1.
No. See, the point. No, sorry. If you look at this, any states will have two possible inputs. Input is whether it is 0, whether it is 1. Okay. Based upon the 0 or 1, I am going to changing my present state to the what? Next state. Correct.
Okay.
This is how you can model the what? Millet model, Moore model, right? If this circuit will get the random input like this. This is getting what input is? 0 or 1, correct? 0 or 1, but finite length sequence I am getting here. Based upon that, I should write a state diagram that I should convert it as a state machine. If I'm giving very long length sequence to this, whenever this particular pattern matches, we should detect as output as 1. So that for my states, I have two inputs. Input is 0 or input is 1. If input is 0, I should see that which state I should go. Input is 1, which state I should go. Right? Each state, how many?
Actually, what happens in Miller only we have to choose when 0 or 1 only. The next state equal to reset state or next state. In more we
Correct, correct.
don't require that assert state, right?
In more also, if input is 0, look at this. This is my present state. Got nothing is present state. If input is 0, I'm staying in, it remains in the same state. One input. If input is 0. If input is 1, where I'm going?
When it comes to last
Got one
statement,
state.
when 1 0 1 only we get the output out equal to 1 1.
Where?
So program-
That is what in Millet model requires less number of states. In Moore model requires number of bits plus 1 states. Millet model, number of bits 1, 2, 3, 4 bits. How many states are there? 4 states are there. In Moore model, plus 1, extra 1 state. But I said that Millet model is what? More sensitive to the noise because our output depends only on the present input. Change in the input will affect the output. So this is depending only on the present state.
So for me, just to play in place of that state, replace the next state. Maybe I think.
Your voice is breaking. Can you repeat again?
When it comes to 1 0 1 1 state, just put the next state equal to SR state, sir. I think maybe we get the output, sir.
Both. When it is 1, I should go to the SR state.
Yes, sir. 1 0.
Replace this by SR state. Sorry.
We don't require any conditions, sir. We don't require any if and S conditions. Just to get the next state equal to SR state.
And actually, we will be getting after once you detect the sequence again, you will be getting 2 states, right? Input is D is equal to 0 or D is equal to 1.
Here you put the condition.
No, this works fine. This works fine, no problem.
So once
state
you
is
detect the
equal
pattern, don't require that 0 or 1, right?
No, man, you should understand this. This is an infinite long length sequence I'm getting, right? It is an infinite long length sequence. I should work for all the patterns, right? Whatever the sequence and continuous patterns I'm getting, I should detect for that. Once I detect the sequence, maybe I'll be getting 0 or 1. Again, next I'll be getting 0 or 1.
Okay. I understood, sir.
Okay, let me clarify this, nothing to worry. I'll be clarify this in the next session. Okay, you can work on this assignment. In the next session, we will be going with the dynamic pattern detection. So what is the use of the dynamic pattern detection? We'll take examples on that. And likewise, you can use, if you see any state machine, how you can write the Verilog program is like what we did today. You follow the same techniques. Okay, same way you can write a state, like many state machines you are working on in the digital part, right? Different kinds of pattern. So you write a Verilog program. So in the next session, let me start with the dynamic pattern detection. What is the use of the dynamic pattern detection? Okay. So any questions from the online student? Can you kindly go ahead? Now I request all of you to fill the attendance, online students. You fill the attendance now. Regarding Monday holiday, they will put it in the WhatsApp group. By today, end of the day, they will put a message in the WhatsApp group regarding sessions on Monday. Okay, let me stop the session here. We will continue in the next session.